welcome back to EE for everyone. Welcome back to the second installment of our ESD monitor series. I'm having a lot of fun so far, and I hope you are too. We're going to pick up right where we left off, and we're going to dive into some architecture planning, some high-level design for this monitor. Let's dive in. So we'll find ourselves back at the computer, and this time with a pretty simple goal. We want to sketch out some thoughts, some ideas for the series. The design of this monitor is we need a current source, you've got your ESD Mat, and then what you have in here is you have a little DMM, and your current source, your voltage measurement, and your ESD Mat are all with respect to ground. And that's beautiful, because what happens is when you design it that way, if any of those contacts to ground gets broken, you're going to get a strange measurement. Let's say that instead of a current source, let's say we have a voltage source. And the voltage range we were looking at before was 9 and 16 volts. Let's start that right at a 12 volts. I don't know if that's going to be perfect, but we'll add a question mark. Let's pretend for a moment that it's going to be 12 volts. And let's say we add a series resistor. Why is that important? Well, 12 volts is always safe for a human, but you might pass enough current through a person that you could burn them. Like if there was a short or a lower impedance than normal, like 12 volts, couple ohms, you could really hurt someone with that. And just to prevent that, we'll add a series resistor, and let's just say something, I don't know, like a mega ohm. Something like a mega ohm. This is just spitballing. Something in that range. Big approximate. And then if we just go ahead and connect that to our test, so that could be either your operator or to the ESD Mat, what you could do is you could set a threshold that will cause a trip. So now we can pretend that's connected to our mat. We can pretend that's connected to our human. What's going to be really critical here is that the voltage source over there is isolated from mains and connected to earth ground. Great. So now we've simplified our current source with this resistor, and let's just think for a moment. Okay, so now we have this measurement. How should we actually measure it? Yeah, that's a great question. Now, normally for something like this, we'd have our 12 volt rail. So let's just 12 volts, and then we'd have some kind of shunt current source, shunt voltage reference with a resistor in there, and then you have your Vref. We've commonly used 2.5 volts or 1.2 volts as voltage references in the past. However, I think I might have thought of a simpler way, and this is coming back to our mega ohm current heavy air quotes source. And basically what that means is we're now measuring a voltage that is ultimately dependent on the resistance of the load and this 12 volt source. And if we trust that 12 volt source is 12 volts for a moment, what we might be able to do is just have a simple resistor divider. Because if we have a resistor divider as our reference, that's actually exactly the same thing, because our mat is functionally a resistor. So if we know that our whatever the value is up here, if we know that's 1 mega ohm or 2 mega ohms or 10 mega ohms, as long as we know that resistance, we're actually just measuring the output resistance compared to that 1 mega ohm, and we can set a Vref that's proportional to that 12 volt input. Then it doesn't matter what your test voltage is. It could be 9 volts, 10 volts, 12 volts, 8 volts. It's just everything is proportional, and it's all based off of those resistor values. I like that a lot because it gets rid of a relatively complex active device that's more expensive than a simple resistor. And to be completely honest, I think this is going to be more accurate than a discrete current source or even a regular current source, than a current source I see and a precision reference. I think this resistor divider method is going to be very simple and work very well. Now, the biggest issue I see with this is that we're going to need to be very careful about how we're making this decision. And let me talk a little bit more about that. And we're going to use a simple comparator for testing our positive threshold, and we're going to use a second comparator to check our negative threshold. So if we go below that lower threshold or above that upper threshold, we're going to throw an error. We've got these two nets that we need to connect, and both of these are going to have a little bias current. I'll just put this as IB, and that could be sourcing or sinking current, but ultimately that's a few nanoamps or a few microamps depending on this device. Just thinking for a moment, if this is something on the order of 10 mega ohms, because that's the trip thresholds we saw in our previous video, and maybe we make this a 10 mega ohm as well, well, if we've only got a 12 volt source, that means we're talking about nanoamps or microamps of current that could be going through this loop, and now all of a sudden having two sets of that bias current might be a problem. So one thing that we might want to leverage would be a buffer, and that's basically an op-amp circuit. Basically what that will give us is we'll need to deal with one bias current, depending on our op-amp, and then it will give us a buffered version of the same voltage. Now, if we were to add a resistor and a resistor, we could actually make that a non-inverting amplifier, and that could be helpful as well because that could let us add some gain so we could reduce our test voltage. So that's just something to keep in mind, that for one reason or another, having that ability to add gain and reduce the amount of bias current may be helpful, especially if we want 2 or 3 different ranges. Now, the other thing to keep in mind is that we need to build different circuits here, right? We're meant to monitor a mat and a person, and those might look a little different. Except for really they don't. They don't really look that different at all. They're actually exactly the same circuit with just a different trip threshold. Of course, when you're connecting directly to a human, this upper resistor becomes more and more important because you need to limit currents. Maybe we'll add 2 or 3 of those in series. Might need to add some ESD hardening to this signal here through some kind of diode, but that'll add leakage currents. We have some details to work out, but we're not worried about that right now. What do we really have? We have a few different things. We have a current source, and we've decided that's going to be a resistor. We have a monitor, which is ultimately going to be a comparator. And then we're going to have maybe a third thing, which might be a buffer. And ultimately some kind of alarm. In this case, we're going to have some LED indicators hooked up to those comparators, and we're going to add a buzzer. Just for sake of simplicity, I think we're going to go for a built-in speaker where the actual oscillating element is built into the actual speaker. So just apply 12 volts and it buzzes. I think that'll be very helpful. Maybe we'll add a switch or something so that we can disable that. Like in the other one, buzzers can get very annoying, especially when it's a faulty wire in your ESD mat. It makes you want to rip your hair out, which isn't exactly ideal. So, yeah. I'm pretty excited about this architecture. I think this is a really simple way that we can try to implement what they did. Maybe it'll work as well, maybe it won't. Hey, throw your comments down below. If you know more about ESD mat monitors than me, which I basically just looked at the spec sheet, so you probably do, and you've got some obvious reason why this is going to be terrible and not work at all, well, let me know down in the comments. Of course, this is only as good as the grounding strap, so I don't think it'll be worse than what we were doing before. It's just adding that little bit of monitoring and fault detection so that if we had a broken wire in our mat to ground, we would know. Thank you to our Patreon members and those that decided to become channel members for EE for Everyone. Really appreciate your monetary contribution. I also appreciate all the time and attention for those that have been watching our videos. Most of all, I hope that you learned something great today, and I hope to see you again soon. Hope you're looking forward to our next videos, where we're going to be walking through some detailed design, getting this into T-Spice, and starting to work out some of the more nuanced details and design compromises here. Setting thresholds and looking at input bias currents, picking components, all that good stuff. And I hope you're looking forward to the next steps of this design. That's all for now. See you in the next one. Bye.